Hello, welcome heroes. Today we're going to talk about pipettes or micropipetters. So you're probably familiar with these, probably used them many times in Amino Labs kits, the inoculating loops. Now, sometimes these are used for streaking cells, but sometimes these are used for collecting certain amounts of liquid. And so you'll see one says 1 microliter, one says 10 microliters. And the general idea there is that in the end of this loop, we'll just zoom in here, roughly about 1 microliter of liquid will actually fit in that loop and actually be held there. So you can use that for, it's a close approximation, but as you become more pros and you start doing more authentic research, you start to need to choose the volumes that you need to move around, okay? And so today's topic, micropipetters, they are tools that allow you to move small volumes of liquid around very accurately, all right? So that's a micropipette. Now let's just look at them and learn a little bit more. Okay, so this is a micropipette, and they all kind of look similar in that they've got this little hook here. This is how you hold it. So this little hook goes above your hands. There's a little button up top here in general. Sometimes for pipetters you push all the way down and it ejects, but generally the vast majority have a little button here that helps eject what are called tips. We'll talk about that in a minute. It's got a little dial here, a little gauge, and this tells you how much liquid it is currently set to move, right? And then there's a little dial here. Again, different pipetters, there's so many different brands. They might have slightly different ways to change the volume, but in general, you will move the top button or some dial around that button, and you'll see it's changing here, okay? So yeah, that's a micropipetter. Maybe the second thing here is because you need to move small volumes of liquid quite accurately, very rarely, if ever, you'll find a pipette that does it all. And so you'll often have 3, 4, 5 different pipetters that will do a certain range of volume that you need to move, okay? So for example, in this one here, on the side, and often you'll see this on micropipettes, this goes from 0.5 to 10 microliters, okay? And these are microliters, so that is 1,000,000 times less than a milliliter, which is 1,000,000 times less than, 1,000,000 times less than a liter, 1,000 times less than a milliliter. So these are very small volumes, but this pipette handles very, very small, whereas this one's a little bit larger. This handles between 10 and 100 microliters, okay? This one here handles 0.1 to 1 milliliter. So in other words, 100 microliters to 1,000 microliters, okay? So yeah, many different pipettes, and I'll just quickly show you. There's even more. So this is it's a pipetter. I don't know if I guess it wouldn't technically be a micropipetter. You can see it's got a giant tip on it. This one goes from 1 to 10 milliliters, so much larger volumes of liquid, okay? And we have another kind which is called a multi-channel pipetter, okay? On these, which we call single-channel pipettes, they have one place where you can put tips and draw liquid up and down. In this case, you can actually put 8 tips on this one and pipette up and down a certain volume at the same time. So if you're doing if you need to do lots of tubes, often multi-channel micropipetters are a really good tool to have, okay? And you can see on this one, it's even a different volume range. So this multi-channel goes from 50 to 300, okay? So I guess one of the first things you need to know is what volumes do your micropipetters handle, so that as you're doing experiments, you start to know which ones to grab. All right, the second thing here, I keep talking about tips. I'll show you what they are. So when you're using a pipette, you never want to have the liquid go into the pipette. because it'll clog the pistons and it might wreck the O-rings, and essentially it'll break the pipette. So what we do is we use plastic ends that fit on the tips of these. Okay, so I'll just put one on here. I'll describe a little more about putting on a tip later, but you can see here there's a plastic tip. The liquid that you draw into this, the tips are designed to pull in an appropriate volume for that micropipette. All right, so this one only pulls in 10, so for these tips, which are designed more or less for this size, if you pull in 10 microliters, it's not going to go in to the pipetter. It's going to go like up to here or something, okay? And so the liquid should only ever touch the tips. It should never go in. And when you're done, you just dispose of the tips into a disposal container. And then you're ready to go. A new tip that's sterile, it's not contaminated, so you can continue your experiments, okay? So if you had tried to draw liquid directly into this, not only would you wreck your pipette, but you're going to contaminate it, and that will lead to cross-contamination across your samples. Okay, so tips are really important, and just like there are different sizes of pipettes, we have different sizes of tips. So these are the small ones for the P10, these are the larger ones for the P100, and these are the largest ones here for the P1000. Okay, and I use these new terms P1000, P100, and P10. That's science speak. So you'll notice this goes up to 10 microliters. So often scientists will say that's called a P10, a pipette that does 10 microliters. Right? This one goes to 100, P100. This one goes to 1,000 microliters, a P1000. Okay? So if you ever hear that in a lab, now you'll know what everyone is talking about. Okay, so now let me just show you a little bit about putting a tip on. So when you're putting a tip on, you want to firmly push down and just give a little twist. You don't want to put all your weight on it by any means, but you do want to apply enough pressure so that the tip stays on and it seals properly. Okay? You'll know if you pushed it on too hard if it's difficult to eject the tip. Right? If it's really hard, then you know you've put it on way too hard. Okay? And that can actually damage your pipetter. So just like everything in life, pipetting takes a lot of practice, and you get to know the instruments you're working with. Okay, so that's how you put a tip on. And then we have this little button I mentioned earlier, the ejector button. Okay, and so essentially you just push this down, and you can see it's going to push down and push the tip off. Okay, so I'm just going to push the button over the disposal here, and there it goes. Okay, quite simple. And of course you want to use appropriate tips for the pipette that you have. All right, so now let's move on to just some general know-how of pipetting. So let's actually talk about the act of pipetting and what that entails. So first let's start with the volume. Okay, so just like you have different pipettes of different volumes, the dials on pipetters are often not consistent between brands. Okay, so sometimes it's a little hard to know what number it actually is talking about when you're trying to change it. In these pipetters that we have at Amino Labs and find in our store, you'll see a little line here, and that designates a decimal place. Okay, and so right now, the way this reads is this would be 20.1 microliters. Okay, and part of knowing what volume you're at on a pipetter, sometimes you need to know the context of what pipette it is. All right, so yeah, on these ones it's easier because you can see a decimal point line here. So 20.1, I could turn this both directions. Let's say I wanted to go to 50. I would keep going here. 50.2. Let's go to 50.2. There we go. So 50.2. Okay, and I can turn this all the way up to 100 and down to 10. Now, often in pipettes, you can go past those ranges, but you don't want to because it'll actually decalibrate your pipette, and you won't pipette any volumes accurately if you're out of this range. They're just not designed for it. So always pipette within the range of what your pipette says. Okay. So I'll just give you another example here. This is the P10. You can see the decimal point is in the middle here. So right now, this would read 0.74 microliters. Okay, so that's a very, very small volume. And there we go, that's 1, 2, 3.03, right? And then the largest one here, the decimal point is way up here because actually you'll see this is in milliliters on this, right? So those are microliters, this is mils. And so right now we would read this as 0.150 milliliters, which if you convert that to microliters, that would be 150. Because a microliter is 1,000 times smaller than a milliliter, okay? So you're essentially just moving the decimal point 3 spaces, 1, 2, 3. So it'd be 150 microliters. Right? And we can, just the same as the others, we can go up. And once it hits a 1 up there, then that would be the 1 milliliter, 1,000. Okay? So this would be 327. Okay? So that's the dial. That's really important for setting how much you want to move. Now let's quickly talk about how do you actually pipette, right? And so there's 2 general motions. One is called to aspirate, and this is to pull in liquid. And then there's to dispense, which is to push out liquid, okay? And the way you aspirate is you push down on the thumb here, you push down, and then you insert in the liquid. Of course, we need to have a tip on there. Insert in the liquid, and then you slowly pull, let your thumb release, and that'll draw up the liquid. Okay, so again, that's to aspirate. And then when you want to dispense, you just push down, and actually you can push all the way. So there's 2 stop points that are on most pipettes. So as you're practicing this, you'll see if you push down, you'll reach a resistance point. That's the first stop point, and that actually indicates you're at the volume that you want to draw up. So if you're aspirating, you would push down to that first stop point, insert into the liquid, and then slowly let your thumb come up, and that'll pull in, hopefully, 327 microliters of liquid. You would then move it over to another tube, destination, discard container, and to get rid of that, or to dispense, you push down. You'll feel the first stop point, but then you can actually, and that should get rid of most of the liquid, but then you actually can push all the way down, and that'll push extra air through the tip to make sure that you've gotten all of the liquid outside of the tip. Okay? So 2 stop points. This is really important, and yeah, you want to make sure you don't try to aspirate by pushing all the way down, because you're going to push so much air out, and then you're going to draw up that and then the extra amount, right? And you're just not going to pipette accurately. And one of the main points of pipetting accurately is so you can have consistent experiments, you don't have variability in your data that's confusing. So yeah, you really want to practice and do well with your pipetting. Okay, so that's really it. We set the dial, we talked about aspiration and dispensing, we talked about tips and how you never want to directly pull liquid into the pipettes. So now we can actually do a practice here. Alright, so now we're going to do the pipetting exercise. I've got 3 pipettes, I've got all my tips. We have a source tube that contains water in it, and we have a couple of destination tubes that we'll pipette into. Alright, and I do have a little scale here which I'll talk a little bit about later. Okay, so let's go ahead and use the P100 again. Goes to 100 microliters, so you call it a P100. We're going to find the appropriate tips. They're underneath. Go. There's no labeling on this box. Sometimes the boxes might have labeling, but you kind of just know by the width of the tip and then the width of the tips. So we're going to push down, give it a little twist. All right, and so again, we've got first stop point is the volume you've selected, and then the full down is only for dispensing, right? So for the Amino Labs activity that you'll find on our website, you pipette 2 different volumes of liquid, of water. You pipette 50 microliters and you pipette 450 microliters. Okay, so part of this is finding which pipette to choose, right? You need to choose the right one. We're going to start with the 50 microliters, and then we'll go from there. Okay, so we'll get our tube ready. We're going to unscrew it here. You might want to have a tube rack. I'm going to open up my small tube. I'm going to put the 50 microliters into the small tube here. All right, and okay, so we want to, again, make sure we're at the right volume, 50, 50 decimal 0. We want to push down to the first stop point. We want to insert into the liquid just under the surface. So you only want to go a couple of millimeters under the surface. Then you slowly let up your thumb. That'll pull in or aspirate the liquid. See, that's what 50 microliters looks like. And then we're going to put into the destination tube. So we're going to put the tip into the tube here and just push down, and you'll notice I'm pushing all the way down. I was looking at my thumb there as I was saying pushing all the way down. And so actually what you should do is your tip shouldn't be submerged. You might have seen some bubbles there I saw in the corner of my eye. That's not ideal. You want to, when you're dispensing, you may just want to barely touch the surface, and you kind of need to retract as you're pushing down. You don't really want to be at the bottom of the tube and just push the plunger all the way down and create lots of bubbles. Okay, there we go. So that was an aspiration. Again, first stop point, aspirate with thumb up. While you're in the liquid, go to your destination tube, dispense, push all the way down. All right, and then I'm going to get rid of my tip. I'm just going to press the eject. There we go. Now, the next one I need to do is 450. So I need to choose the right pipette. 450 microliters is 0.45 milliliters. Okay, and so I'm going to set this to 450. 450, there we go. I'm going to get the correct tips here. Let me stack these other ones, get them out of the way. I'm also going to open up my destination tube. Alright, so again, we want to push, give it a little twist. Alright, so same thing happens here. We want to push down to the first stop point. Okay, you don't want to, again, not all the way down. First stop point. Insert just under the surface, a couple millimeters. Gently lift up your thumb, let it settle for a moment. Make sure the liquid is at the right level. And then when we put in this tube here, I'm going to zoom in a little bit. So we're going to push down. And see how I'm lifting up the tube as I go up? Just so that it's not submerged and creating lots of bubbles, right? And then I pushed all the way down, but all the liquid was out of the tip, so that was successful. Okay, there we go. And then I'm going to eject that tip to the discard container. I'm going to put on the lid, just like that. All right, and so for the Amino Labs exercise, you're going to do this a number of times. You'll have a number of tubes if you get the kit online, but I just want to say a few things about the scale, right? So this is a little scale. It's fairly inexpensive, and the important thing is that it goes to 3 decimal places. It's kind of hard to get an inexpensive 3 decimal place scale, and this one's pretty good. There are other types of scales that are often used in labs. They're called analytical scales. They actually go to 4 decimal points, and they're very accurate, but I think this should work pretty well for your practice here. And the general idea is that water has a density of 1 gram per milliliter. Okay, so if you have 1 milliliter of water, it should weigh 1 gram. right? And so what we're doing here, the idea is you would weigh your tubes dry, then you'll pipette your liquid in, and then you'll weigh the tube with the liquid in it, and then you should be able to subtract the weight of with water to the weight without water, and then you'll get the weight of the water, right? And so I'm not doing that right here, but you can see here 3 decimal places. It is wavering back and forth a little bit, right? But ideally, an empty tube. Okay, just a quick tip here. If you live in a dry area and you have static electricity, the static electricity from your body or your sleeves of your lab coat or even the tube, you can attract or repulse, and it'll actually change the volume. So you need to be careful about that. When you set up a scale, it should be on a flat surface, very stable, no vibrations, so you can kind of step back, no wind blowing down on it, right? Because these are very sensitive. It does go down to 1 milligram, right? And yeah, so when you use a scale, you typically will tare it, and to tare means to 0, and then you put on your tube. So when you weigh your dry tube, you're going to put your dry tube on and you're going to tare it, and then you'll fill that tube with your liquid, 450 microliters, for example, and then you'll weigh it again. Or you'll probably tare your scale just before you use it and weigh the second one. You can see it's wavering a little bit. It could be because I'm breathing on it and it's literally the wind of my voice is like hitting it. So just be aware, these balances are very sensitive to movements in the air and static. Okay, and then from there, once you get all of your tubes dry weight and wet weight, what you get to do is put them into a spreadsheet, which we'll talk about next. Oh, maybe I'll just talk about a couple of pitfalls here. So things that can go wrong. So one of the things that can go wrong, I've seen this happen a couple of times, and I hope it doesn't happen to you, is especially on the small micropipetters, so P10, you can even get some that are called P2s. They go from 0.2 to 2 microliters, so very small volumes. What can often happen is when you're putting a tip on, if you are on the edge and you push down, the tip box can actually tilt over, and if you push too hard, it'll actually tip right over and you'll snap the end of the pipette off. All right, so that's a pretty big fail, and it means you basically need to get a new pipetter, and these are they're not cheap, right? So you want to be careful. If you're using a pipette, just grab the tips, or especially if you're using a small pipetter, grab the tip box and pick up the tips from there, okay? So that's something I've seen several times before, okay? Another tip is pipetting too fast. So you might want to just like pull up and let your thumb off or push down really fast, and that can lead to inaccuracy, especially if you're just lifting up really fast, because bubbles can get pulled in, especially if it's a viscous liquid. It might not go up in time before you pull out of the liquid, and so you want to just push down slow, let it equilibrate, put it in the liquid, and then slowly lift your thumb up, and it'll draw up and be a lot more accurate. So you don't want to pipette too fast. Another big pitfall is the wrong stop point. So somebody out there is going to be doing this despite watching this video. They're going to push all the way down, insert it into the liquid, draw it all up, right? And that's going to be a completely wrong volume, and in fact it could even possibly pull liquid into the pipette. All right, so that's a big no-no. You want to make sure you remember the first stop point. Okay. The next is tips not secure. So maybe you don't push down quite enough on the tip, and that can lead to leakage. You don't get a perfect seal at the top, and so when you're pushing or pulling air, it just leaks and then it doesn't pull in the right volume. So you do want to give a nice firm push and twist. But again, you'll learn and you'll get the feel for it. If you push it on too hard, it'll be really difficult to get the tip off, and that can lead to breaking your pipette. So it's all about practice. And then the last potential pitfall I want to mention is out of range, and I've said this many times. You do not want to move the dial so that it is out of range of the pipette, because it's both going to decalibrate the pipette, and it's not even going to be accurate anyway. So why are you doing it, right? So this is 100 microliters or 0.1 mils. This is the bottom end of this pipette, and you can see I can go past a little bit, and you might think, oh, I need 80 or something, and I can get there with the pipette. But when you do that, it's not going to be accurate. So always stay within the range of your pipette. All right, well, enjoy pipetting. It takes a lot of practice, but it's an essential part of continuing your journey. All right, home gamers, so we're here in the Amino Labs Beat the Prof or Robot Spreadsheet. So we just learned about pipetting and did a bit of the exercise in that last video, and now I'm going to show you the spreadsheet and how you can do some data analysis. And so on this first spreadsheet tab here, we've got a little bit of information. The idea behind this activity is you're trying to pipette better than this pipetting robot, right? Or you're trying to pipette better than what a prof would like you to do in a university course. And I'll describe a little bit more about this afterwards. There's a little bit of data on this first tab, or information about data, raw data, process data, visualizing data. So have a look at this. On the raw data tab, this is where we input our information. All right, and raw data is data that you get directly from your experiment. It's not processed in any way. You get it directly from a piece of equipment, or you write it in your notebook. In this case, you wrote the weight that was on the scale, right? So that's raw data. Later on, when we do some processing, you'll see in the future tabs here that becomes processed data and interpreted data and all that. So I've already pre-filled my dry tube and wet tubes for the 450 microliter and the 50 microliter. And when you do this, it'll automatically do a subtraction of the wet tube mass minus the dry tube mass and give you the mass of the water. And what you'll see here is there's actually a number of spaces for you to input data after subsequent tries. So you may not beat the robot or the prof on your first go, and it's important when you're doing science to not delete or overwrite old data to try and look good or to do anything. It's not about your pride, it's about uncovering fundamental truths of the universe. So you put in your data here, you see how it goes, you do another experiment, try it again, you put your data here, and so on and so forth. Okay, let's move on to the next tab here. So we're going to do a little bit of statistics here. You might have learned about the mean or average. This is an average of several samples. You have standard deviation, which gives you an idea of how consistent your pipetting is. So were the different tries very different? Were they all over the place? Or were they very similar? If they were very similar, you'll have a low standard deviation. And then we have the coefficient of variation, which is a little bit more of an advanced calculation. But it's here. It describes it, and you can look it up on the internet. There's lots of information there. So this tab is really about beating the robot at coefficient of variation. So they say, the creators of the robot say they get a 0.2% or a 0.4% depending on the different pipettes that you use or the different volumes. And so we can see in my try ones, I actually didn't beat the robot in either. I was actually kind of close in the 450 microliter test. So they say 0.2, that was 0.34, so that's pretty close. But when we look at the 50 microliter, I I was actually way off. All right, we were like, yeah, way off compared to the robot. So, yeah, I didn't beat the robot. I'm not too upset. That's its only job. Okay, and then now we're on, this is a more standard calculation that you'll encounter, especially when you get to uni, where you're looking at the error of your, yeah, you have a theoretical that you're trying to get, and then you have your experimental, and you do this little calculation on the side here to get your percent error. And university profs usually say that if you get less than 5% error, then you pass, all right? So that's the beat the prof here. And then we have systemic error, which is a calculation not used in university classes usually. It's something that is used to measure the robot's accuracy. And essentially it's almost like averaging the percent errors rather than looking at them individually. So if we go down here, we have my first try. So the top here we have percent error, percent error, percent error. Actually, I did quite well. I had a low percent error, far lower than 5%. So for the 450 microliters, I could definitely say I beat the prof. So that's exciting, nice. And if I look at the systemic error, I'm actually lower than the robot's listed maximum error values, which is 2%, and I'm at 0.5, so that's fantastic. If I look at the 50 microliter, however, I got 0 on one of them, 2 and 6. So I didn't beat the prof on one of those pipettings. And if I look at the systemic error, I did not beat the robot. It was actually kind of close, because 2%, 2.67, but I did not beat the robot there. Right? And so you can see, if you just keep your raw data, fill out the further raw data tables, try 2, try 3, try 4, you might actually see yourself improving, right? So initially you might have a number of reds, you leave those there, you try again, and then maybe you have less reds and less, and by the end maybe you're all green, right? Maybe you beat the robot. So yeah, I encourage you to just practice. That's an important part of doing science, getting good at pipetting and understanding how the pipettes work. The last tab here has a little bit of visualization of that data, and so it's kind of hard to tell right now because I've only done one try, and you say 100 and 100, and so that makes the graph like very wide here. If you input all your data, you're actually going to see it zoomed in, but the university 5%, and then you can see how I did on the 450 and the 50 microliter, and so I was below that, which is great, and systemic error and so on and so forth. And so use this spreadsheet as a way to kind of learn how you might log data, present data, how you might process that data by doing averages and basic statistics, how you might use charts to represent that data. So really that's part of this spreadsheet, is for you to dive into that world. Okay, so happy pipetting. I hope you get all green